The prompt for this question is, how do you make 0.5 liters of pH 1 molar phosphoric acid buffer with a pK of 7.21 with sodium dihydrogen phosphate and disodium hydrogen phosphate? So first you have to figure out which one is going to be X and which one is going to be 1 minus X. And for this question, sodium dihydrogen phosphate is going to be X, and disodium hydrogen phosphate is going to be 1 minus X. So how we do that is so then we have that. Then once you figure that out, you can set up an equation. Alright, so after you do that, you can use the Henderson-Hausgebausch equation, and you will get that the pH equals pKa plus log of HPO2 negative 4 all over H2PO4 negative. Then once you get that equation, you can start plugging in your numbers. So you get the pH of 7 equals 7.21 plus the log of 1 minus X over X. And as you can see that using here and here, you can plug that in. So 7.0 equals 7.21 plus log of HPO4 over and then so log of 1 minus X over X equals 10 to the negative 0.21. So from here you would move that over, which gives you 7.0 minus 7.21, which gives you that negative number right here, that exponent. And then you go 1 minus X over X equals 0.617. And then you get 1 minus X equals 7 X. So from here you gotta figure out what X is. Therefore, when you solve for that, X will give you 0.618584112. So using that number, you can go and you can figure out what the conjugate base total molarity is going to be and what the acid's molarity is going to be. So you figure that out by this. So you know that the conjugate base plus the acid is going to equal 1. So that means that conjugate base is going to equal 1 minus the acid. Therefore, the conjugate base is going to equal 1 minus the number that we got for x, 0.6185, 8412. So that means that the total is going to be 0.3814158. Okay, so that is for the conjugate base. Now you have to figure out the acids total. So you know that one minus acid is going to equal 0.61858412. From here, you're going to get 1 equals 0.61851. 618588412. A for the acid. And then so you're going to add that 1. So you're going to, okay, so then you get 1 plus 0.61858412 equals the acid. And then you're going to get 1.61858412 equals 1 divided by 1.61858412. So the acids total is going to be 0.61782. Sorry, that's not the right one. The total is going to be 0.61793,632 for the acid. So after that, you have to get the concentrations and then you get the amount. So, which we did the concentrations on the other side actually. So the concentrations of these is going to be, here it is 0.61793,632. And then this one is 0.38141,588. So, get that. So in order to find the amount needed, we do 0.5 liters times 0.61793632 times 1 mole all over and then times 119.98 all over mole of NaH2PO4. And then that total will give you 37.11 grams needed of NaH2PO4. Now, you have to get the amount needed of this one. So when you do that, you do 0.5 liters times 0.381411588 liters times mole all over times 141.96 over mole of this. And then you get that to equal 27.07 grams. All right. And that is how you figure out how to get the amount needed in 0.5 liters of sodium dihydrogen phosphate in disodium hydrogen phosphate. So for sodium dihydrogen phosphate is 37.11 grams, and for disodium hydrogen phosphate it is 27.07 grams.